Okay, hello guys, today we'll be exploring the limit theorem in design and analysis of algorithms. So it's actually just a very simple concept. What limit theorem tells, okay, first of all, limit theorem is just used to tell how two functions f of n and g of n are related. Okay, now f of n can be uh, omega of g of n. It can be big O of g of n, or it can be theta of g of n. I'm sure you guys already know that omega is the best case. I'm not writing it down. Omega is the best case, and big O is the worst case, and theta is the average case. Okay, so that is what this limit theorems help us to find. So it can be big O, omega, or theta of g of n. So we'll be just given two functions, f of n and g of n, and using the two functions, okay, sorry, using the limit theorem, you'll have to find the relation between two functions. So of course, like if f of, let's say f of n belongs to big O of g of n, then that also means that g of n belongs to omega of f of n. Is this very how do I say that? Like it's understandable, right? Yeah, it's very intuitive. Like if one function is worst case of second function, then the second function is best case of the first function. All right. So okay, what limit theorems tell us is, let's say we have two functions, n4, fn is equal to n4, and g of n is equal to n cube. Alright, two polynomial functions. Now, um, according to the limit theorem, n raised to 4 is the best, it belongs to the best case of n cube. This is what limit theorems tells us. Alright, it's just a theoretical concept. We don't need to dive much deep into it. But yeah, and so n raised to 4 is equal, it belongs to the omega of n raised to q. Omega is this symbol, you know. Now in physics you might have studied this ohms, omega, like that. Or this is actually big omega. We have small omega also. This you might have studied in wave equations in physics. All right, and we also have n cube belonging to worst case of n raised to 4. So n raised to 4 is the worst case of n cube. See, okay, let's just take, we consider n4 as n square and n cube as just 10. So this was n square, nothing changes. It's just for the visualization part. I'm just gonna replace n raised to 4 with n square and n cube with n. So yeah, in the graph, you can see the n cube, sorry, no, sorry, the big O of n, the linear function will be a straight line, but the n square will be like a parabola curve, right? So this straight line at higher values of n the quadratic function will have a higher value of y. So if we check for a value of y over here, you can see once again. I think I kind of messed up. Okay, for okay, let's say for x is equal to 10. Let's say x of 10 is over here. So at this point, let's say it's like this. You can see the value of y for x and square is a lot bigger as compared to big of n. So yeah, you can visualize the difference, right? Over here it's like 1,000 or something, while here you can say it's like 70. So for n square it could take up for n square it will actually take 1,000 iterations, but for n if it will take only 100 iteration if the size of the n is equal to 100. So oh sorry, 10,000, right? N square 100 square will be 10,000. So yeah, this is the limit theorem. Okay, so now how do we write it in a formula? I'll explain how that formula derived also. It's super intuitive and easy to understand. So what that formula tells us is limit n tends to infinity, because asymptotic means a very large value of n. So limit n tends to infinity, f of n by g of n, if this value becomes infinity, if this value becomes infinity, because see, if f of n is n square and g of n is n, you just cut this n square and n, you get n. And when n tends to infinity, it becomes infinity, right? Or if you have n cube also, then you get n square, same situation. So yeah, in this case, we can say that first function is bigger. So f of n belongs to best case of g of n. It belongs to the best case of g of n. Alright, now let's say my it was reversed. So n by n square, it becomes 1 by n square, which becomes 1 by infinity, which is 0. So if f of n by g of n limit n tends to infinity becomes 0, then we write f of n belongs to worst case of g of n, or big O of g of n. If the first function is smaller, f of n is less than g of n. So it can be like, you can compare any two functions. So let's take n and n raised to 5. You can easily see that this is less than, and n is less than n raised to 5. So n belongs to big O of n raised to 5. Alright, so yeah. And if it's a constant, that means both the function are in the same magnitude. So n raised to 5, like, okay, we can say that n raised to 5 is it's similar to 2n raised to 5, right? In asymptotic notation, we don't consider this constants. So we kind of neglect it and we write theta. N raised to 5 belongs to theta of 2n raised to 5. So over here, what you will get is a constant. In that case, what you'll write is f of n belongs to theta of g of n. This is equal, or yeah, approximately equals. All right. So these were the three main classification in of the limit theorem. So the important point to note over here is that if f of n is smaller than g of n, this means that f of n is the one second, even I get confused sometimes. If it is smaller, right? So what you'll get over here is 1 by infinity, which is 0. And in case you get 0, it is worst case. Yeah, okay. So f of n is smaller than g of n. That means f of n is worst case of g of n. Kind of opposite of the logical thing, but it is what it is. You have to kind of cram this whole equation. And actually, we have one advanced version of limit theorem also, where we have different formula for big O and small o. So for big O, it is less than infinity. If the limit becomes less than infinity, then we write it as big O. If it is equal to 0, which we have seen here already, if it is equal to 0, it will be 1 by infinity, right? F of n by g of n, which is 0. I'm sorry for this handwriting. Not used to the I'm not used to writing with mouse, but yeah. If it is 0, then it is big of g of n. So yeah. Over here they have written small o, but yeah. Anyway, it's O, right? Nothing much to worry about here. You just draw medium O and they'll consider it. They can't differentiate big O and small o in your exams. But here is where you'll find issues, the big omega and small omega. Over here, if you get infinity, then you have to write small omega. If it is greater than 0, I think this situation will never occur, because if you get a constant, you just write theta. Alright, I'll tell you what to do. If you get constant, you write theta. Fn belongs to theta of g of n. If you get infinity, the limit answer as infinity, you write small omega. If you get 0, you write small o. So whatever we discuss here, you write the same thing, but instead of big O, you write small o. Instead of big omega, you write small omega. This will work. I'm not sure why these cases are even given. This doesn't make any sense. Less than infinity and modulus also. So it's not infinity but a constant. But that should be in theta, right? So yeah, you can kind of ignore these two cases, big O and big omega case. It will make much easier to understand. Now we can see some questions in this using this video. Actually, you can just refer this video on your own, but I'll quickly go through it. So we have this 2n4, 4n cube, n square versus 9n cube, 7n square, and 6n. So by seeing this question only, can ignore this n cube and n square in the first function and n square and n terms in second function. A much easier way to do it. So it becomes 2 and 4 and 9 n cube. You can ignore that 2 and 9 also. So it just becomes n4 and n cube. And when you check the limits, n4 and n cube. So that becomes n, and n tends to infinity, so it becomes infinity. And for infinity, what do we have is it will become omega. Infinity means omega. Is it the answer? Yeah, f of n is big of g of n. In the second question, the n raised to 1 by 2 and n raised to 1 by 4. Again, the same thing, you just cut n raised to 1 by 2. See, what is n raised to 1 by 2 by n raised to 1 by 4? Isn't this n raised to 1 by 2 just twice like squared of n raised to 1 by 4? Wait, I think I'm writing it wrong. This one, right? Okay, wait a second. Since the two terms are equal, you can see 1 by 2 and 1 by 4. We just write these fractions over here. 1 by 2 and 1 by 4. What does it become? 0.5 by 0.75. No, sorry, 0.5 by 0.25. So this becomes 2. Yeah. So you can see the numerator is leading. So n raised to 1 by 2 by n raised to 1 by 4 is equal to n raised to 1 by 4. And n raised to 1 by 4 when n tends to infinity becomes infinity. So again it's omega. F of n is equal to omega of g of n. So again the same thing. You can actually refer this video. This guy has explained it much better way as compared to my explanation. But yeah. Okay, so now we have this logarithmic functions, and I don't actually remember the logs, but yeah, he's using this logarithmic property. When you have log b base a, you can write it as log b with a new base. So log b base c divided by log a base c. So yeah, something new to learn over here. And so actually, let me try to solve it. So I'll kind of get a new space to solve this. We have log um, log 2n or log n base 2 as f of n, and g of n is log 3. I mean log n base 3. Okay, so now I'm supposed to compare these functions. Actually, if I'm not wrong, it has higher base. So, wait, what does it do? Logarithmic function. Kind of, I want to search the expansion. Log expansion. Dude, I am not able to find it. Log equation. This one. This is what I wanted to see. Y is equal to log x base b. So b raised to y is equal to x. Alright, so if my base is higher, then the function will grow slower, right? So in this case, I can see my g of n is smaller as compared to f of n. So f of n is greater than g of n. So when I divide them, this is small f by the way, f of n by g of n, I'll I'll get a constant over here. I won't get 0. I'll get a constant. So I can write it as f of n is equal to theta of g of n. I mean, you can't write it in exam, in your university exams. I mean, you won't get full mark. You can write it, but you won't get full marks. For getting full marks, you need to use a complex method like this. But yeah, in case you don't remember the complex logarithmic formulas, you can write this and will most likely give you like 70% of the marks. If it's a one marker, you'll get a half mark. Two markers, you will most likely get 1.5. Alright, so log n base 2 and log n square base 2. Isn't this just n by n square, which is 1 by n, which is 1 by infinity, which is 0? And what does 0 mean? I forgot. Okay, 0 was big O. Yeah, 0 was big O. Okay, you can remember it like this. 0 as O, right? 0 and O. Similar. Good. Nice observation over here. And infinity equals omega. Oh, okay, not this one. You have to write a small one. 0 is small o and infinity is small omega. So yeah, let's check this answer. It's theta, the third one. Yeah, it's greater than 0. So yeah, this is theta here written here. Then the fourth one, I got 1 by infinity, which is 0, which is O, big O. Or yes, you write small. Alright. Sorry guys, I did a mistake here. Because I don't know about logs. I missed that log of n square will be 2 log n, which will be 1 by 2, which is a constant. So this makes it a theta of g of n. So yeah, uh, don't go to such shortcuts. These won't work. But okay, I'll just control Z it. But yeah, at least we remember the formulas. So if you get 0, limit as 0, write it as small o. F of n is small of g of n. If you get the limit as infinity, you write it as small omega. If you get a constant, neither 0 nor infinity, if you get a numerical value, you write it as theta. Okay, yep. I guess that's it. So now we have log n by log n square. I'm quite sure it's 1 by infinity, which is omega. But his logarithms, bro, you can never be sure. So 1 by infinity, yeah, 0.
So, our conclusion is f of n.
1 by infinity. Okay, I think I made a mistake, yeah. So 1 by infinity is 0. 0 is small o. So yeah, written small, correct. Then 6 1 log 2n versus n raised to 0.1. Okay, this is an interesting one. So I hope you know the basic distribution, right? Like logarithmic functions are much faster than linear polynomial functions n raised to x. So log of n would take much lesser time as compared to n raised to any power. But dude, I really need to learn maths. It's true for x greater than 1 for sure, greater than or equal to 1. But how does the graph for, I'll just check at once, com n raised to 0.1. I have no idea how that graph will look like. Okay, x raised to 0.1. Oh, okay. I mean, it's still log x. Yeah. So yeah, this is true for any x greater than or equal to 0. Oh, sorry, not equal to. It should be greater than 0. You can see from this graph actually the blue the for higher values of x. If I zoom out, I zoomed out too much, but you can see the blue line is on the top, which means the logarithmic function is greater than the polynomial function. What if I write x square or just x? With just x would be higher, right? Even sorry guys, I'm making few mistakes here. Let's see if it's what's the answer first. Okay, he's using El Hospital rule where you differentiate both the numerator and denominator when the both the numerator and denominator are tending to infinity. Okay, so he got, yeah, this is correct, what I told earlier. So log n would be smaller than n raised to anything, n raised to anything greater than 0. So when you divide log n by n raised to anything, n raised to a constant, which is greater than 0, you will get 1 by infinity because n is going to infinity, right? So you'll get in n raised to infinity. You can think of this log n to be something like n raised to 1 and n raised to that constant, you can think it as n raised to 2. So when you cut this, you get 1 by n, 1 by infinity, which is 0. And for 0, we write it as small o of n. F of n is equal to small o of g of n. F of n is equal to or belongs to small o of g of n. Oh, wait, he didn't do the other questions.
Okay, so for this, hello everyone.
Alright, I'll try to quickly solve the remaining ones. These are very intuitive actually. N cube and 3 raised to n. We all know that 3 raised to n will be much larger as compared to n cube. So this will also become 1 by infinity. So 1 by infinity is 0, 0 means small o. Okay. And then we have n versus n log n. So again, n is smaller than n log n, which is again 1 by infinity. Yes, smaller by bigger. So smaller by bigger, you can consider it as n by 1 by infinity if they are in different magnitude. If it's in the same magnitude like log 2 and log 3 in this case, then it will be you'll get a constant. If it is in different magnitude like n and n log n, then you will get 1 by infinity, which is 0. So this will be small o. And then we have n square versus n log n. So we all know that n square is a worst case complexity than as compared to n log n. So it will be infinity by 1, which is infinity. So n square will be best case of n log n. It will become infinity, right? Yeah, so it will be best case or uh, small omega over here. Then we have n versus log 3 raised to n base 2. Okay. We have log of exponential. That's a really weird function to say the least. Let me just try to graph it. log base 2. Can I write base? No, I don't think I can. Alright, 3 raised to x versus what? X, right? And well, both of these functions seem to be linear. Why is this line only going till here? That's so weird. Okay, maybe 3 raised to x becomes a very large number after. Oh shit, it's actually going till 650. That's incredible. Because 3 raised to 650, you guys have no idea how large number that will be. It will have millions of digits, to say the least. It's incredible that Esmus is doing the calculation. But see, I'll consider them to be in different magnitude. This is log of exponential and this is just linear. And we have the second one having less is greater than the first one. So it is 1 by infinity. Okay, sorry, I should have made this first because first one is linear. Alright, so first one is smaller than second one. So 1 by infinity, which is 0, which is smaller. I kind of want to solve it using the limit theorem, but I don't think I'll be able to do it. N by log 3 raised to n. Yep, not gonna happen for limit n tends to infinity. How the hell do we even solve this, man? Oh, okay, I think I have an idea. Yeah. Oh, okay. It's actually 1 by log 3 because see, 3 raised to n. You take this n out and multiply it to the denominator, right? So this n and n gets cancelled 1 by log 3. Alright, guys, it was a constant, my bad. It was a constant. So in this case, f of n will belong to theta of g of n. Let me see if this guy has part 2 of this asymptotic notation 5. When was it made? December 28, 2020. That will be a lot of scrolling actually. Alright, asymptotic. Yeah, this one. Wait, I saw this one, right? So 7th one. Just want to confirm whether my answer is right.
In this video, we're going to talk a little bit more about.
Dude, kidding me. I just solved one random question in that video. Asymptotic notation 7. Okay. Then in which video has it solved this one? Big omega and logarithms. Okay, I think he didn't solve the rest of the questions. But yeah, in this calculation you can see it's theta of g of n. Alright guys, that's it. I'll be taking leave now. Hope you understood the limit theorem. You might want to refer few more questions to understand it better. And yeah, take care. Bye. Have a good day.